volume, and you have a little note sheet there. If you want to go ahead and just fold that in half to start with, you can see we have this awesome little cover for it. We're finding the volume of right rectangular prisms. So go ahead and put your name in there and the hour. And an hour on that front little piece there. So you just fold it in half. Oops, let me get this out of the background there. So you just fold it in half, and then you can open up back to your notes. Let's just fold it in half like that. Awesome. All right, and then if you open up to the inside page there, you can see at the top, this is our skill that we're working on for this. We need to be able to find the volume of a right rectangular prism. And then we just listed right underneath of here, these are our learning intentions. These are our learning targets. We want to be able to understand that the volume of a right rectangular prism can be found by filling the prism with multiple layers of the base. And we're going to apply our formula to find the volume of a right rectangular prism. Gosh, there's a lot of vocabulary in there, and let's just make sure that we all understand what we're talking about here. So first off, what is volume? When we're finding volume of a 3D shape, we have to find out how many cubic units fit inside of it. So if you see here, we have two little examples for us pictures. So this first one is, we've talked about this before, it is a right rectangular prism. So this is the shape that we're going to be talking about for all of our examples, right? Rectangular prism. Have to fit it in there. Right, rectangular prism. Because we know that the faces, all the sides are rectangles, right? And our base is also a rectangle. So it's a right rectangular prism. And then what we're going to do is we're going to see how many of these little cubic units, it's like those little tiny blocks that you've seen before in math. We want to know how many of those does it take to fit inside of here to fill up that right rectangular prism. So this is just a cubic unit. And we've talked about how this is different than when we were finding just area, because now we have volume, so it's a 3D shape. That means it has a length, a width, and now it also has a height, okay? So when we're talking about volume, we're just filling that shape up. So if you look down here, we have an example. Here's our right rectangular prism, and you can see that we just put those little cubic units in to fill the base layer, okay? So let's count how many cubic units are on our base. So we want to do our length and our width here. So I'm just going to count. We have 1, 2, 3, 4, 5, 6. So there's 6 there. So I'm just going to label this bottom part 6. And then we have 1, 2, 3, 4 going on our width. So it's 4. So 6 by 4, that is one of our base layers. Okay. Now all that they're doing over here is they're just taking that base layer and we are just filling it up. So here's our first base layer and another base layer, and we can count how many bases does it take. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 layers of that base. Okay. Now if we were finding the volume, we could go through and we could count each one of these little cubic boxes, cubic units, to see how many it takes to fill that whole thing up. But I don't know about you guys, I do not want to do all that counting, okay? So we have to see, is there an easier way that we can figure out the volume of a shape, okay? And that's where our formula comes in. So we see, like on this example right here, when we have our base, we know it's a 6 by 4. So if I find just the area of that base, I know that that shape is a rectangle, so it's going to be area equals base times height, or length times width, right? So I have area equals 6 times 4. On the count of 3, what's 6 times 4? 1, 2, 3. 24. So I know that there's 24 cubic units in just that base. Well, now if I have 8 layers, could I figure out how many cubic units are in there? What do you think? What would I do? Anybody have an idea? Put your hand on your head. Hand on your head if you have an idea. You think you know what we could do. Logan, what do you got? We're going to take 24 times 8. If you agree, give me some spirit fingers. Yeah, 24 times 8. So now, good thing we have our calculators out today. I'm not very good with my facts of 24. So we're going to take 24 times 8. What'd you get? 192. If you agree, put both hands on top of your head. Nice. 192. And our 192, that's telling us that's how many of these little boxes are in this right rectangular prism. So we would say 192 units cubed, or cubic units. Units cubed. And that equals our volume. Okay, so again, this was the area of the base. And this was the number of layers in our base, right? And then that gave us our volume when we just multiply those together. Okay, so here's the thing, 6th grade. Not every single problem is going to have those little cubic units in there for you to count. Most of the time what's going to happen is they're just going to have the sides, the length, the width, and the height labeled for you on your right rectangular prism. So we're going to take a look at the formula that we can use to find the volume of a 3D shape. So I'm just going to slide down to the bottom of my notes here. And the volume formula, we actually have 2 boxes because there's 2 ways that we can write that volume formula. So let's look at our box here to the far left. We have V equals blank times blank times blank. Well, we know that we could take the length, which is a lowercase l, length, times our width, times our height. And then I just left blanks for you guys to fill in what all of those letters stand for. So we know the large V stands for volume. Whenever we want to represent volume, it has the large V. We know the lowercase l stands for length. We know the lowercase w stands for width. And then the lowercase h stands for height.
There is one thing I want to add, Ms. Gall. When we're writing that formula, you either want to put a uppercase L or like a looped cursive L, because if you just put an L straight up and down, what does that look like? What number does that look like?
Looks like a 1.
It looks like a 1 and it can get you guys confused, right? I made that mistake a lot in 6th grade.
Or it looks like an I, yeah, good call. So definitely you want to put a little loop on your L, or you could do an L like that. Okay, good catch there, Miss Duggan. Okay, so that's one formula that we can use. Another formula that you guys might see sometimes, and if you notice over here when we were talking about these letters that we plugged in our formula, I said lowercase, lowercase l, lowercase w, lowercase h. Because another formula that you might see is where our volume equals, and we use a capital B times a lowercase h. Okay, so let's talk about what those stand for. So again, we still have our V. V stands for volume. But then that capital B, that stands for the area of the base. So kind of like what we did up here where we found the area of that base of our shape first, and then we multiply that times the height. Okay, and then our H still stands for our height. All right, so let's take a look at an example over here where we don't have our little cubic units counted out for us. So we can't go through and count, okay? We have to use our formula from over here. So the first thing that we're going to do, it tells us that I'm finding the volume, right? And I have to show my work in the box. So we know from the rest of our unit, we're always going to start with our formula first. So we're going to put V equals L, again, put a loop-de-loop for that little cursive L, times our width times our height. I just went ahead and put dots in between theirs because we know that it's multiplication on all of those. Okay, then the next step is we're going to go ahead and fill in our length, our width, and our height. We're going to fill in our values there. So we still have V equals. And again, notice we're writing it right underneath, right? So right underneath of L, we're going to put in our length. What's the length on this shape? Annabelle? 12. So we're going to put 12 times. What is the width of this shape? 5. Good job. And then what's our height? 3. Nice job. Okay, so now we're just going to circle and we move. PEMDAS tells us we do multiplication or division, whatever comes first, going left to right. Since it's all multiplication, we're going to do 12 times 5. I'm going to circle that so that my teacher knows this is what I multiplied first. Okay, so you're going to take 12 times 5. I got 60. If you agree, put your hand on top of your head. Awesome. So then right underneath it, we're going to put V equals, now instead of 12 times 5, we're going to put our answer, which was 60, but we still have times 3, so we need to bring that all down. So then we're going to circle, that means that's the next thing we're doing, so we're going to take 60 times 3, that multiplication there. 180 is what I heard. If you agree, give some spirit fingers. Oh, look at those spirit fingers, it's like a party. Nice job. So volume equals 180. Oh, and then what is our label going to be here? What are our units? What do you guys think? Ava? Okay, this time though, instead of, I like where you're going with it, units cubed, because that's what we did up here. But up here it didn't tell us if it was inches or feet or miles, right? Down here it does. Okay, so we're gonna use this, but we're gonna cube it. So it's gonna be inches. And now watch how we cube it. Cubed is going to be a little tiny 3 up in the corner. Little tiny 3 up in the corner. So inches cubed. 3 is because this is a cubic. It's a 3D shape. I also remember it because you're multiplying length times width times height. So you're doing 3 multiplications. So it's 12 inches times 5 inches times 3 inches. Since we're multiplying 3 inches units, that's where we get that cubed from. Say that one more time. Oh, if you put it to the power of 1?
Yeah.
Okay, so anything to the power of 1 is, that's just what any number is, like our 60 is to the power of 1 or 3 is to the power of 1. So we never put that 1 up there. So that's just talking about regular number, like when we did perimeter. Okay, it's not multiplying it times 2 units times each other. It would be like if you were adding. That's a good question. All right, 6th grade. So now that we have this copied down, the back of it is blank. So we're going to have you go ahead and glue this into your notes. So you can use this as a reference as you work through today's assignment.